Okay, so usually when students ask for help on this type of problem, it's really that they want to hear the thought process more so than just doing the problem. So I'm going to walk you through my thought process, how I approach this, and see if it helps you. Okay, so first things first. I always look to define my variables. Step one is always define your variables. Okay, so the question how I usually figure this out is I ask myself, what is the problem looking for? What is it asking for? Whoops, that's not what I meant to do. Come back. Okay, so when I look here, they say how many mailings should the center send to each area of the country? So how many different areas of the country were they sending to? Well, they had 3. They had X, which we'll call let me see, they mailings to the Midwest. Let me pause the video for a second and catch up. There we go. Okay, so I'm seeing East Coast, Midwest, and West Coast. So you can define your variables to be whatever you want. I will call these, so X will call the first one. So X is the number, or actually it makes, why even call it X? Let's be smart about it. E will represent the number of mailings to the East Coast. M will represent the number of mailings to the Midwest. And W will represent the number of mailings to the West Coast. And remember, they're defining as number of mailings. So until you need it, you might want to actually write out number of mailings, if that makes sense. Okay, so now we've got our variables defined. So now I always try to find, next thing I look for is, in this type of problem, is our objective. Figure out what is the thing we're trying to min or max. Write the objective. My goodness, I apologize. I am under the weather, if you can hear my voice. Okay, doing this with probably the temperature. All right, let's see. So what is the goal? How many mailings should the center, blah, 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 with the least possible cost. So what we're going to do is write an equation about cost. So let's go through and figure out, let's find the information that talks about cost. Okay, so up here I found East Coast cost, Midwest cost, oops, I didn't circle the Midwest part, the Midwest cost, and the West Coast cost. So East is 40, Midwest is 60, West is 60, or 50. So let's go ahead and fill those in. So our cost, our goal is to minimize it, and so our cost is going to be, not colon, equal to, there we go, East Coast, $40 per mailing. The Midwest will cost us $60 per mailing, and the West Coast will cost us $50 per mailing. So there's our step 2. Now we have our objective. Our goal is to minimize that function. So now we have to deal with our constraints. What are the things that are limiting us in the problem? So step 3 is write equations, write our inequalities. You don't need to watch me write. There we go. So write inequalities that relate the variables. Remember, your goal is to find some equations that somehow combined East Coast, Midwest, and West Coast numbers. So when you go back up here, usually in textbooks the problems are not that well written, so it's kind of easy to figure out. Here we see, okay, we have something with 6,000 Democrats. So let's write some equations that relate Democrats. East Coast gets 400 Democrats. Midwest gets 400 Democrats. And West Coast gets 200. So 400, 400, 200. All right. So 400 from the East plus 400 from the Midwest plus 200 from the West, that needs to be greater than or equal to 6,000 Democrats, right? Because they said at least 6,000 Democrats. So, and then I always like to double check 400, 400, 200. Okay, good. Now, we could do the exact same logic with the Republicans. They want 6,000 Republicans, and we get 200, 400, 400, 200, 400, 400. Okay. So 200 Republicans from the East. Oh, I forgot. Oh my goodness, this is how sick I am. I can't remember anything for more than a second. let's see, back to here, 200, 4. Okay, so 200, 400, and 400. And again, that has to be greater than or equal to 6,000. All right, let's go back here and see if there's anything else that we're missing. So we got our 6,000 taken care of. We got our cost taken care of. Is there any other information in here that we need to be conscious of? Each mailing, pardon my sniffles, each mailing to the East Coast gets 400, 200. Mailings cost 40. We already took care of our costs. That's it. There's no other constraints. So here we go. That is our setup. So there's your setup. If you need help from this point, now we look at this and say, okay, of course we have our real world constraints. East Coast, Midwest, and West Coast all have to be greater than or equal to 0. You can't have a negative number of mailings. So now we're going to look at this and say, how do I solve this problem? Can I graph it and look for the solution? Well, you could, but it's in 3D. That's not going to be fun. So we're going to go simplex or dual method. Since this is coming from section 4.4, you don't know dual yet. So simplex is the way to go, just in general. So you're going to have to, it's a minimization instead of a maximization, and it has greater thans instead of less than, so you got a lot of work to do on it. But hopefully the problems that you did prior to this set up the theory. So if you need more, let me know.